So today we are going to start learning about relations and functions. So in the previous two lectures we have seen the basics of sets, the various operations that we can perform on the sets, the properties of sets. So those will be very useful in this chapter. So the first thing that today we will be starting is Cartesian product. Cartesian product of sets. So what is Cartesian product? So we will define it as given two non-empty sets A and B. So we have two sets A and B. Let's say A we have 1, 2, and B we have 3, 4, and 5. So we are given two non-empty sets. Then we have to find all the ordered pairs. So it has to be a group of two elements. So we have to find ordered pairs. So first thing was ordered pair. So here ordered is important. Ordered pair of two elements A and B. So it will not be same as not equal to B A. So if AB is unordered pair, then AB is same as BA. But if AB is ordered pair, then A comma B is different from B comma A. So it's an ordered pair where this was our first condition, and the second was that A should belong to A and B should belong to B, and we will represent it as A cross B. So we are telling about A cross B. So if we are given two sets A and B and we are to find A cross B, cross here denotes the Cartesian product, then we have to find all the ordered pairs A, B such that A belong to first set and B belong to second set. So now for this example, A cross B is equal to, so we will take first 1 here from A and 3 from second. Then we can write 1 from first set and 4 from second. Then 1 from first set and 5 from second. So we are done with 1. All the cases where 1 will come first. Now we will take 2. So 2 from first set and 3 from second set. Then 2, 4 and 2, 5. So this entire thing is a set. So we can change the order of these things. Like we can write 1, 3 after 1, 4 or 1, 5. So that's not important. But but within every pair, the first element, if we take any pair, pick one of these pair, the first element has to come from A and the second element has to come from B. So this ordering should be maintained, but after we have created all the pairs, we can put it in any order. So this is called the Cartesian product of two sets A and B. So we can give a formal definition here in our set builder form. A cross B is equal to A comma B, all the pairs A comma B such that, or we can also denote such that using this straight bar, such that A belongs to A and B belongs to B. So this is our formal definition of Cartesian product. So we will see some more example. So suppose if one of the sets is a null set, then what will happen? So if A is an empty set and B has some elements 1, 2, then how will we form A cross B? So we have to pick, so all the pairs A cross B where A belong to A. So in A we have nothing, so we cannot form a pair with only the elements of B, because for creating a pair we need two elements, and the first element has to come from A, and A has no element, zero elements. So we cannot form any pair. So in this case, A Cartesian product B would itself be phi or null set, that it will have no such pairs, because we cannot form pair with just one element. Now we will take some more examples of where we can where do we see Cartesian products in action, or why are we so adamant about keeping the ordering among the elements within the pair. So let's take an example. So suppose we have to decide the number plates of vehicles. So you know that the first two digits are generally the state code. Now we are also adding India IN symbol outside that, but the first two digits are state codes, and next two digits are some license plate code. Then we will have the actual number. So uh, we have to design number plates. Number plates of vehicles, and A is the set of the first two digits, that is state codes. Let's K for Karnataka, TN for Tamil Nadu, DL for Delhi. We can have many more examples, but for here let's say we take only three states, and next we take the next two digits in the license plate codes. So let these be 01, 02 and 03. So then what all possible license plate codes we can form will be given by Cartesian product of A and B. So it's 3 cross 3, so we will have 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we will write KA comma 01, KA comma 02, KA comma 03, then TN comma 01, TN comma 02, DL comma 01, DL02 and DL03. So you see why ordering is important here, because you can write, you can see vehicles starting with code KA01, but we cannot write 01KA. So ordering is important here. So K comes from here and 01 comes from this. That's why ordering is very important. So another example can be this pair of coordinates of any point in 2D space. So there, if this is our coordinate system where the horizontal axis is x and vertical axis is y, and this is some point P, suppose 1 comma 2. So this will be 1 and this 2. This is not same as 2 1, because if we write 2 1, then it will be here 2 and 1 here. So this point will be somewhere here, this 2 1. So these 2 points are at different places. That's why with change of order of elements within that pair, we get entirely different thing. So that's why ordering is important. So in that example, let A denote all the x coordinates 1, 2 and 3, and B denote all the y coordinates, let's say 4 and 5. Then the points that will be formed in a space, all the points formed in 2D space would be given by Cartesian products of sets A and B. That is A cross B, and you know how to find A cross B. In this case it would be points 1 comma 4, 1 comma 5, 2 comma 4, 2 5, 3 4 and 3 5. So these will be the points formed using this. So now let's look at some properties that we have to keep in mind. So we are given two ordered pairs. So we have pair 1 and pair 2. So these are equal only when the individual elements are same. So suppose we compare 1 4 and 1 5. So we see that the first element is same, but the second element is not same. So these are different ordered pairs. So two ordered pairs are equal if and only if the corresponding first elements are equal. So we have to compare the corresponding first element. First element of this pair is this, and the first element of second pair is this. Similarly, second element with second element. So if the corresponding first elements are equal and also corresponding second elements are equal, so we will call two ordered pairs equal if and only if the corresponding first elements are equal and corresponding second element. So first element should be compared with first element, second element should be compared with second element. If both are equal, then we will say that these ordered pairs are same. So we can take some example here. Let's say x plus 1 comma y minus 2. This ordered pair is equal to 3 comma 1. So this we are given. So we are asked to find x and y. So just now we saw that we have to compare first element with first element. So x plus y with 3. So this is 3 and this is 1. We are given that these are equal. So x plus 1 equal to 3. So x equal to 2 and y minus 2 is equal to 1. So y equal to 3. So using this property we found out the values of x and y if we are given this relation. We can take another example. This is from NCERT. So we are given that x divided by 3 plus 1. So this x divided by 3 complete thing plus 1. This is first pair y minus 2 by 3. This is equal to 5 by 3 comma 1 by 3. So again we have to compare this first element. This is 5 by 3 and this is 1 by 3. So x by 3 plus 1 is equal to 5 by 3, or we will take 1 this side, or we can add here only. So it will be x plus 3 divided by 3 is equal to 5 by 3. So 3 gets cancelled. X plus 3 is 5. So we get x is equal to 2. So x is 2. Similarly, y minus 2 by 3 is equal to 1 by 3. So we will move it this side. So it will become plus 2 by 3. So denominator is same. The numerator will be 2 plus 1, 3. So 3 by 3 is 1. So x is 2, y is 1. Now we will take some more properties. So if we have two sets A and B, and number of elements in A is equal to x and number of elements in B is equal to y, then number of elements in A cross B is equal to xy, that is x times y. Why this is true? Because we have one set, it has say two elements. The second set it has 3 elements. So while forming the ordered pairs, we will pair this point and this point, then this point and this point, then this with third. And we will also pair the second with first, second with second, and second with third. So we will have 3 pairs. Number of elements is here 3, here it's 2. So we will have 3 pairs where this is first element, and 3 pairs again where this is second element. So if it has 2 elements, then for each point here we will have 3 pairs. If we have 3 elements here, then for each point we will have 3 again. So 3 cross 3, 9. Here 2 cross 3, 6 pairs are possible. So this is the property. If first set has x elements, second has y element, then Cartesian product will have x, y elements. And now earlier we had seen that if one of the sets is a null set, then the Cartesian product is also a null set. So we can have another case where one of the sets is an infinite set. For example, the case of we had seen natural numbers or integers. Let's take positive integers only. So 0, 1, 2 and so on. We cannot count it. So one of the elements is suppose an integer and another is some finite set, say 2 or 3. So when we are going to form ordered pair, the first element has to come from this and second from this. So corresponding to each element here we will have a pair. But here we have infinite elements, so the entire cross product, the entire Cartesian product itself will be infinite set. So till now we have been talking about just two sets. We can have more sets, Cartesian product of more than 2 sets, 3 sets at a time. So we will denote it as A cross B cross C. So its definition would be all the triplets. So for 2 we have pairs, for 3 we have triplets. All the triplets A, B, C such that A belong to A, B belong to B, and C belong to C. So just to clarify my point, I will take one simple example. So I have A equal to 1, 2, B equal to 3, 4, and C is equal to 5. So A cross B cross C is equal to so we take 1 from A, 3 from B, and 5 from C. So first of all, how many elements should we have in this triplet? So here we have 2, here we have 2, and here we have 1. So we will have 2 cross 2 cross 1. So we should have 4 elements. Next we take 1 from first and 4 from second, and in C we have just 5, so it will be 5 everywhere. Then we have taken all the pairs where 1 is the first element. Then we take 2, 3 from B, and 5 from C. Then 2 from A, 4 from B, and 5 from C. So these are all the possible triplets with A, B and C. We can also be asked find A cross B union C. So what we will do, first we will find B union C. So B union C, we remember we have to include all the elements that are present in A, B or C in B or C. So B has 3 and 4 and C has 5. Mm, and A is 1 and 2. So we have to find this cross 3, 4, 5. So we have 2 elements here, 3 elements here. So total we should have 6 elements, 6 pairs. So 1, 3, 1, 4, 1, 5, then 2, 3, 2, 4 and 2, 5. So we can be asked A cross B cross C, we can be asked A cross B union C. So here we did it all at once, but we can also do it individually. Like first we will find B cross C. So we will take just 2 sets at a time. So we will find B cross C and then we will get a set of pairs and then one set will be A. So we can do A cross B cross C in that way. We can also be asked say uh, A cross B and we could have intersection here. So we will first find this value and then do the Cartesian product here, or we can have A cross B in bracket and then union B cross C in bracket. So these kind of things will be there. So our first task would be to solve these operations and form a set. So we have to reduce the number of sets and do it. So let's take some more examples. And this is from NCERT textbook. So we are given set A, which is 1 and 2, and set B, which is 3 and 4. Write A cross B, and so first question is write A cross B. Second question is how many subsets will A cross B have? List them. So first we will find A cross B. So this will be 2 cross 2, so 4 elements. 1 3, 1 4, then 2 3 and 2 4. So n A cross B is equal to 4. So how many subsets A cross B will have? So we saw in the previous lectures that if a set has suppose 3 elements, then we will have 2 to the power 3 uh, subsets of that. So if n A is equal to k, there are k elements in set A, then power set of A, which we denoted as set of all subsets, is equal to 2 to the power k. So here this A cross B has 1, 2, 3, 4 subsets. So it will have 2 to the power 4 subsets is equal to 16. We have to list all of these. So in one, it can be first can be empty set, second can be just we pick 1, 3. So let's write down everything. So it will be empty set, then 1, 3, then 1, 4, 2, 3, 2, 4. Then we can pick 2 elements at a time, 2 pairs. So we pick 1, 3 and 1, 4. Next we pick 1, 3 and 2, 3. Next we pick 1, 3 and 2, 4. Then we pick 1, 4, 2, 3. Then we pick 1, 4 and 2, 4. Next we pick 2, 3 and 2, 4. So we have included all the sets with 0 elements, all the sets with 1 pair, all the sets with 1 pair here, and then all the sets with 2 pairs. So here in the set we have just one element, each element we have taken. Here we did not pick any element. Here we are picking 2 elements, 1, 3, 1, 4, 1, 3, 2, 3, 1, 3, 1, 4, 1, 3, 2, 3, 1, 3, 2, 4. Then 1, 4, 2, 3 and 1, 4, 2, 4, and then 2, 3, 2, 4. So we have taken all the 2 element sets. Now we will take 3 element sets. So 1, 3, 1, 3, 1, 4, 2, 3. So we have picked these three. Next I will pick these three. I mean I have to ignore one element. So here I ignore 2, 4. Next let's ignore 2, 3. So it will be 1, 3, 1, 4, and 2, 4. So here I left out 2, 3. Next left out 1, 4. So 1, 3, 2, 3, 2, 4. Next leave 1, 3. So we will get 1, 4, 2, 3, 2, 4. So we have covered all the three element sets. Next all the four element sets. So there is only one set that can be formed. So that will be 1, 3, 1, 4, 2, 3, and 2, 4. So how many elements we have? 1, 2, 3, 4, 5. 5 here. Then 1, 2, 3, 4, 5, 6. 6 here. Then 1, 2, 3, 4. 4 here. And 1 here. 6, 4, 10, 5, 15, 1, 16. So we get all the 16 sets. So these are the subsets of A cross B, that is the Cartesian product of A and B. So we are given A and B, we found out the Cartesian product, which is itself a set of pairs, and from this set we have to find all its subsets. And when you are doing this, always verify that you you are getting the expected number of subsets which we calculated beforehand. So now I will quickly take another example. This is again from NCERT textbook. So the Cartesian product A cross A has 9 elements, among which two elements are, so A cross A has 9 elements, so clearly A should have 3 elements. So out of those, 2 are given here, so it's minus 1, 0 and 0, 1. So 2 elements are given out of 9. Find set A and remaining elements of A cross A. So we are given that NA cross A is equal to 9, and we had earlier said that if NA has X elements, NB has Y elements, then A cross B will have X into Y elements. So where both sets are same, so NA times NA is equal to 9. That is NA whole square is equal to 9, or we will get NA, we will write it here, NA is equal to 3. So A has 3 elements. Now we are given 2 elements. So remember, the first element in the pair has to come from first set and the second from second set. So minus 1 comes from A. So we have A is equal to, it should have 3 elements. So minus 1 comes from A. We write minus 1 here. And then second element has to come from second set, which is also A. So 0. Then here first element is 0, it has to come from A. 0 we have already included. Then second element is 1, it has to come from this second A. So we will write 1. So we found 3 elements, and we were expected to find 3 elements in A. So now we know A. So the first part is done. And then we can, from here, it's very simple. We can easily calculate the remaining elements of A. So we will write the complete A. It will be minus 1, minus 1, minus 1, 0, minus 1, 1. Then 0, minus 1, 0, 0, and 0, 1. Then 1, minus 1, 1, 0, and 1, 1. So the question had the remaining elements of A cross A. So we were given minus 1, 0. So minus 1, 0 was given, and 0, 1 was given. So we will remove these two, and these 7 are the remaining elements of A cross A. So you need to practice more in order to get fluency in this. So with this we will end today's lectures. Thanks for watching.